All right, so today we're going to talk about, and you're going to work with medians. Of triangles. And a median of a triangle. Is a segment whose endpoints are on a vertex and the middle of an opposite side. So a median of a triangle is a segment. It sits on a vertex and the middle of an opposite side. So if we draw a triangle and label it ABC, and then we take a segment that has endpoints on a vertex, so vertex C, and the middle of an opposite side. So the middle of side AB would be about here. I'm going to call it D. And if I connect those 2 points, if I connect D and C, all right, DA is congruent to DB because D is a midpoint, then DC is a median. Connects a vertex to the middle of its opposite side. Every triangle has 3 medians, and they are concurrent at the centroid. Theorem 5.7, called the centroid theorem. And the centroid theorem states the medians of a triangle intersect at the centroid which is two-thirds the distance from each vertex. the medians of a triangle intersect at the centroid, which is 2/3 the distance from each vertex. And then let me show you what that looks like. So if we take a little bigger triangle, and label it ABC again. And then on side AB, try to estimate the middle and put a point there and call it D. And then do the same thing for side BC, estimate the middle, put a point there, call it E. And then for side CA, estimate the middle, put a point in the middle, and call it F. Then connect A and E. Connect F and B. And now when you connect C to D, try the best you can to go through this point where the two medians have intersected, even if you got to bend it a little bit. So C to D looks kind of like this. I'm going to try to make this red point in the middle. This red point, I'm going to call it, it's gone. I'm going to call it X. X is the centroid. Now, what the theorem said is that the centroid is 2/3 the distance from each vertex. What that means is f of x is 1/3 of the distance to the vertex. All right? So I want you to write these formulas down, but then I'm going to show you a real shortcut to find these distances, okay? I'm going to start with f to x. Fx equals 1/3 FB. XB equals 2/3 FB. F to X is equal to 1/2 XB. All right, so F to X is half the distance that it is from X to B. So if you know X to B, you divide it by 2, that gives you F to X. All right, and then 2 times Fx is equal to X to B. All right, and look here, F to X, that's the distance from the side to the centroid. All right, so that same rule, these formulas apply to all of the medians. So the distance from the side to the centroid is 1/3 of the whole median. Okay, that applies to dx and it applies to ex. So watch what happens here. If x to b is 10, what is the distance from f to x? F to x equals 1/2 x to b. What's half of 10? 5. So x to b, or f to x is 5. Look, short piece, f to x is the short piece. From the side to the centroid is the short piece. From the centroid to the vertex is the long piece. You see how the short piece is always half the distance of the long piece? All right, so if e to x, is that the short piece or the long piece? It's the short piece. If this is 4, how far is it from x to a? 8, very good. You see it? Short piece is half the long piece. The long piece is twice as big as the short piece. So if you had to find C to D, and all you were told was C to X, and let's say C to X is 12. If C to X is 12, how far is it from X to D? 6. So how far is it from C to D? 18, very good. You just add the two segments together, right? Because F to B, how far is it from F to B? Good. And what's left? A to E. A to E is equal to 12. Good. So can everybody see the difference between the short piece and the long piece? Okay. The short piece goes from the center to the side, or from the centroid to the side. The long piece goes from the centroid to the vertex. The short piece, all right, is always 1/3 of the entire piece. So C to D divided by 3 is 6. All right, 18 divided by 3 is 6. A to E, AE is 12. And 12 divided by 3 is 4. That's your short piece. And the short piece times 2 is the long piece. F to B, from F to B, if you were given that distance of 15 and you were asked to find the two smaller pieces, well, you take FB, you divide it by 3, here's 5, that's the short piece. And 5 times 2 is 10, that's the long piece. All right, so that's how you use that rule to find all of the different lengths of these medians. Okay? Anybody have any questions on medians? They go from a vertex to the middle of a side, vertex to the middle of a side, and vertex to the middle of a side. All right, then your practice for today is going to start on page 339. Problems 1 and 2. And then over on the next page, problems 5 through 10. So page 339, problems 1 and 2. And then over on the next page, page 340, problems 5 through 10. And as a reminder, the assignment is to finish the practice problems in your notebook. Once you have finished the practice problems, check focus for an electronic assignment and transfer your answers from the assignment to the electronic assignment. You're supposed to complete the practice problems first. Once you've completed the practice problems, then check focus for an electronic assignment. Not yet.